We're going to introduce what's called the multiplication rule. It's an extension of the idea of independence. And what we can talk about is what happens when I lose my pen. Oh, there it is, dropped it. What happens when one event follows another? So A to B, but we want to know what the chances of this whole string of events are. Now, if the events are independent, then in the probability of A times the probability of B gives me the chance of the probability of both A and B occurring. Notice the and there, both A and B occurring. And this is if they're independent. Independent. So for example, I have two dice. For some reason they do red and green dice. I've seen red and green dice, but I've never really played with any because I was never really a gambler as much. And so if I roll both of these dice, the probability of any given event on any given pip is 1 in 6. And the probability of any given pip on this is 1 in 6. So the probability of, let's say, rolling snake eyes, 2 ones, right? So the probability of rolling snake eyes is going to be 1/6 times 1/6, which is equal to 1/36. And we can actually build, if we wanted to, you have die 1 and die 2, and I'll just put it, okay, and we can build a list. Well, all the possible outcomes for die 1 are 1, 2, 3, 4, 5, and 6, and all the possible outcomes for die 2 are 1, 2, 3, 4, 5, and 6. This table would show, right, 36 possible outcomes. If I can draw, sorry. Should use my ruler tool. But for right now. And so, rolling a 2 into 6 would occupy that particular outcome on the grid. And this grid is going to be 6 by 6 or 36, and any particular combination. Rolling a 3 and a 2, though, right? Rolling a 1 and a 1, there's only one chance where that comes, but rolling a 3 and a 2, let me change my colors here really quick. Right, so rolling a 1 and a 1, right? 1/6 and 1/6. Because these dice are separate. Rolling a 2 on the first die and a 3 on the second die is 1/6 and 1/6. 1 in 36. Right, that's rolling a 3 on the first die and a 2 on the second die, and that's this position here. But notice there's another thing that happens. I could have this space here, and that would be the probability of rolling, let me put it, a 2 on d6 number 1 and a 3 on d6 number 2, or the probability of a 3 on d6 number 1 and a 2 on d6 number 2. And we're going to have to make up something to deal with the or. But for right now, independent events do that. Now, if B does depend on A, and so let's go back to our imagined card game. Let's say we're sitting down and no cards have been drawn yet, and we want to know the odds of probability of drawing a Queen of Hearts given a King of Hearts in that order. So what's the probability of drawing King of Hearts and on the next draw drawing a Queen of Hearts given that King of Hearts? And so the probability of drawing a King of Hearts is 1 in 52. And the probability of drawing the Queen of Hearts is 1 in 51. And so, again, I'm not going to run to the calculator. 2562. And 1 in 2,652. Alright, that's the chances of those two cards popping up. You sit down at the table, that's your odds of getting those two cards in that order. And so we say the probability of A and B is equal to the probability of A times the probability of B given A if they're dependent. And so when we have probabilities coming in a series, we get what's called the multiplication rules. And the dependency or independency of them determine if we can multiply them or not. All right, that kind of wraps up section 2 here. I'm going to go into section 3 in the next video.